Hey guys, so today we're going to talk about a few of the prerequisite requirements to get to the next actual topic. So I really want to get to the quadratic formula, but we have to make sure we understand complex numbers, how to work with them, and how to simplify radicals before we can do that. So let's start with I. So you remember at the beginning of the year we talked about the whole number system? Yeah, now is the then, the later. So if you think about it, when we're solving quadratics, there are three possibilities. Either we have two solutions, it's regular old quadratic crossing the x-axis twice. It's got one solution, the vertex is on the x-axis, or no solution, something like this. And we're actually going to look closer at these guys because no solution isn't exactly right. It's no real solution. So let's talk about some non-real numbers. So this, the real number system, we had all kind of mess with that. You either learned it or you didn't, whatever. There they are. But this whole real number system is just a tiny sliver of the numbers. Just a little line, a little piece. To talk about the rest of the pieces, we need the other sliver that makes it the plane. I. What is I? I is defined to be square root of -1. Like pi. Pi is the ratio of a circle's circumference to its diameter. We just called it pi, okay? E, it's a special number that's e to the x is the derivative of itself. Calculus, yeah, whatever. But there's certain special numbers that we just give them names. I is one of them. I is the square root of -1. I is the square root of -1. So what times itself gives you -1? I. Okay, that's what it means. That's it. So that means that I squared, I times I is -1. I times I is -1. We just defined it. That is what it is. So that gives us the imaginary line and the real line that makes all the complex numbers. Now it's important to realize that we write them in a certain way. So we have a real part down here and an imaginary part over here. We write the real part, some number, let's call it A, plus the imaginary part, some other number, B, I. A plus BI. That is the standard form of a complex number. So here we have 1 plus pi I, whatever. -3 minus 2i, that's just how we write them. So the real numbers and the imaginary numbers together make the complex number system. So again, well, that's pretty much what I just said. So let's say we have the number 4 over here and 4i over here. Well, if we look at this number in the complex plane, that would be 4, the real part, plus 4i. It's these two number lines forming an entire plane of numbers. And those numbers together are called the complex number system. Okay, so you don't need to know this yet, but this is the polar grid. We're talking about I, so in order to talk about I, we need to discuss where it came from, how it came to be. To do that, we need to talk about a different graphing system. You're used to the rectangular coordinate system, the Cartesian plane, the x and y axes. Here, we're talking about this plane. It's a polar grid. It's kind of not a plane. It's made of concentric circles, okay? If you think about anything that deals with repetition, sine and cosine are the biggest examples. They occur repetitiously. They repeat. Their values are the same at certain angles. I might be looking at this and like, where on earth does this use? Flying, like airplanes. They use this for navigation. Yeah, so polar grid is actually useful. Maybe not to you, but to somebody. But in order to talk about where I came from, you need to understand that this is what we're looking at. However, I'm going to simplify it by just looking at some special pieces of it. This vertical line here and this horizontal line here. So it's basically going to look like the Cartesian plane. It's going to have x-axis and a y-axis, but it's actually these angles, okay? And the way we notate a polar coordinate is with its magnitude, its size. How big is it? 1, 2, 3, 4. Which circle is it in, or is it in between them? So you could have like 2.3 or whatever, it doesn't matter. And the angle it makes with the x-axis here. So how many degrees is this? Well, it's between 30 and 45, somewhere, I don't know, 35, go with that. But here we go. Again, this is just to discuss where I came from. You're not gonna have to reproduce this. You're not gonna be asked about it. This is just for your information, so you understand that, oh yeah, I is actually a thing. So again, like I said, I just took the horizontal and vertical axes there, the real line and the imaginary line, and I put them in a nice little Cartesian plane looking thing, so it's easier to understand. So I'm only going to be talking about these special angles. If we're talking about the real numbers, remember how it had those concentric circles? Well, I'm just going to use tallies. Instead of a circle there, a distance of 1, I'm going to put a tally there. 2, 3, etc. So the tallies here, really shouldn't put numbers on them, count them, are the magnitude. Okay, these are magnitudes. Yeah, I didn't want to put numbers because these are I's. Well, that's kind of, these guys, the vertical ones are I's, 2I, 3I. These are real numbers, 1, 2, 3. These would also be real numbers, 1, 2, 3. Because remember, it's a circle, right? So this whole thing is 1, 1, 1, 1. They're all ones. It's just these are positive I's, these are negatives, and these are negative I's. But it's magnitude, size, 1. These are all just 1, 1, 1, 1. Okay? Don't talk too much, whatever. So this right here, let's just go 3I and 2. So if I had that point, that would be 2 plus 3I, right? Okay, who cares? We're interested in the nice ones, the ones and the I's. We're looking for I, right? So if I were to write this point right here, let me change that. This point right here as a polar coordinate. The magnitude, R, is 2, and the angle is 0. Okay, sure, whatever. Let's write this one. This is actually just I, right? This is 1I. Well, the magnitude is 1, right? 1. Again, these are all 1. And the angle is right here, 90 degrees. So this is I. I is 190. Now, this red one really isn't important, so I'm going to erase it. The blue one is. I is important. The other important one, -1. So how do we write -1 here? What's the magnitude? 1. Okay. The magnitude is 1. So -1 is 1. But what's the angle? 180. Okay. So I is the square root of -1, right? That's what we're trying to figure out how that came to be. So in order to multiply with polar coordinates, here's how you do it. You multiply the magnitudes, the r's, the first coordinate, and you add the angles, the second coordinate. So I squared, okay, let's do it. I times I squared, let me change my color back to red. I squared, well, that's I times I, which is 190 times 190. Okay, sure, whatever. This is multiplying here. I multiply the magnitude, so this is 1 times 1 is 1. I add the angles. 90 plus 90 is 180. Now, what number is 180? -1. Okay, so this equals -1. look at that. I squared equals -1. I take the square root of both sides. I get that I is indeed the square root of -1. Ta-da. So I is a thing. There actually is a number, I, that when you multiply it times itself, it gives you -1. It's just not in your usual system that you use. So it's in the polar system instead of the rectangular system. Okay? So let's look back at this guy. Let's see. This is a problem from the beginning. If b is 0, it's actually really easy to solve a quadratic. Just isolate your x squared. X squared equals -1. Well, what times itself gives us -1? Ah. And in order, you just square root both sides. Don't forget, though. Don't forget, whenever we take a square root, we always do plus or minus. Because what's 3 times 3? 9. What's -3 times -3? Still 9. So we're not sure what it could be. It could be either one of those values. So in this case, x would equal either square root of -1 or negative square root of -1. No, you can't multiply on the inside. That doesn't work. This is a square root. You can't multiply in there. No. But what can we do? What is the square root of -1? Ah. Negative. Ah. That's what x is in this case. So there is an answer. It's not a real answer. It's an imaginary answer. It's part of the complex numbers. I and the real numbers are both part of the complex system. But the answer here is not a real number. Doesn't mean they don't exist. They perfectly do exist. In fact, if you're an electrical engineer, you'll be dealing with these intensively. Extensively? Sure. Impedance. That's what you're going to do. The opposite of current flow deals heavily with I. So if you do anything with electricity, be familiar with this. That's it for this one. I'm going to pick it up in a minute with another one. See ya. Thumbs up.